Okay, let's dive right into this. You know, for centuries, we've looked up at the night sky, trying to see the secrets of the cosmos. But what if the most profound messages aren't meant to be seen at all, but to be heard? Today, we are talking about decoding a brand new language from the universe, one that's whispered by the most mysterious objects out there.
So, what are these whispers? Well, they're gravitational waves, actual ripples in the fabric of space-time itself. We're talking about events so incredibly powerful, they literally shake reality. And if we want to hear their stories, we first have to learn their language.
The source of these cosmic whispers is something with a bit of a mouthful of a name, an extreme mass ratio inspiral, or EMRI for short. Just picture this, a small black hole, maybe just a few times the mass of our sun, caught in the gravitational grip of a supermassive black hole that's millions or even billions of times bigger. It doesn't just plunge in, oh no, it spirals, making millions of orbits over hundreds of thousands of years, and with every single loop, it's broadcasting its story across the cosmos. And that right there brings us to what scientists call the million orbit problem. Because hearing this cosmic story is one thing, but actually understanding it, that's a whole other level of challenge. It's like being handed an epic poem written in a language that's completely alien to us. This is the absolute heart of the problem. A single EMRI event can spit out a gravitational wave signal that contains the information from over 1 million orbital cycles. That is an unbelievably long, unbelievably detailed, and just incredibly complex message that we have to somehow pull out of all the background noise of space. So what makes this cosmic poem so dang difficult to read? Well, first off, the orbit isn't some nice, clean circle. It's an eccentric, wobbling, dizzying dance. On top of that, the supermassive black hole is spinning, and that spin literally twists and warps space-time around it, making the path just unbelievably complicated. Then you've got the fact that this faint signal is buried in years and years of cosmic static. And finally, it's not just one clear note. Think of it more like a complex musical chord, a symphony of tens of thousands of different frequencies or harmonics, all overlapping, all of which have to be perfectly picked apart. And look, don't just take my word for it. The very researchers behind this breakthrough say it best. These waveforms are among the most challenging to model in all of astrophysics. This really is the Mount Everest of gravitational wave astronomy. For years, astrophysicists have tried to solve this, but their tools were, well, let's just say they were a bit blurry. Go back to that epic poem we talked about. Now imagine trying to translate it, but your dictionary is incomplete and full of really rough approximations. You might get the general idea, sure, but you're gonna miss all the nuance, all the beauty, all the poetry. And this comparison here really shows you why. On the left, you've got the old kludge models. The name kind of says it all. Think of them as trying to listen to that complex symphony, but only hearing the loudest, most basic note, what physicists call the quadrupole, while completely ignoring the thousands of other harmonics that actually give the music its richness. But on the right, the new FEW model, it's designed to hear the entire symphony in full, glorious, high fidelity. So what happens when you use those blurry tools? Well, you get the volume of the signal, its actual strength, wildly wrong. These older models could be off by a lot. They might overestimate a signal's strength by 60% or underestimate it by 40%. That means you could be chasing ghosts that aren't there, or even worse, completely missing a real cosmic whisper that was trying to tell you something. But that all changes now, because researchers have just created a powerful new universal translator for these cosmic signals. This, right here, is the breakthrough that finally cracks the code. It's called Fast EMRI Waveforms, or FEW for short. At its core, it's a new software that can generate the precise, complete, fully relativistic waveform for one of these million-orbit inspirals with absolutely incredible speed and accuracy. It is basically the complete dictionary we've been waiting for. The real genius behind FEW is its two-step process. First, there's an offline step. This is where all the heavy lifting happens. It precomputes a massive library of every possible word or phrase in this cosmic language. Then there's the online step, which acts like a lightning-fast translator. When a real signal comes in, it just rapidly assembles those pre-made pieces to find a perfect match. It's not calculating everything from scratch. It's translating in real time. And how fast are we talking? Get this. A waveform that represents millions of orbits, that took hundreds of thousands of years to happen,
can now be generated in about 100 milliseconds. That's a fraction of a second. It's faster than you can blink. That is an absolute game changer for analyzing data from future observatories like LISA. So, we have the translator. We can finally understand the whispers. The big question, the really exciting one, is what are they going to tell us? This is about to open up entirely new frontiers in science. Yeah, this isn't just about collecting more data, it's about fundamentally rewriting our textbooks. We can finally put Einstein's theory of gravity to the ultimate test, right at the very edge of a black hole, the most extreme environment in the universe. We can use these signals as standard sirens, kind of like cosmic lighthouses, to measure the expansion of the universe itself with ridiculous accuracy. Each whisper is a key to unlocking one of these enormous cosmic questions. Just how precise are we talking? For measuring a black hole spin, the uncertainty can be as low as 10 to the -7. Now, that number sounds tiny and abstract, so what does it actually mean? Well, to put it in perspective, that's like measuring the distance from New York City to Los Angeles and being accurate to within the width of a single human hair. It's just staggering. And with this new tool, our observatories, especially the upcoming LISA mission, are going to be able to see so much farther into the universe. This table shows we'll be able to detect some of these events out to what's called a redshift of 15. Redshift is basically a cosmic time machine. The higher the number, the further back in time we're looking. A redshift of 15 means we'll be seeing things that happened when the universe was just a baby, only a few 100 million years old. You know, for all of human history, the supermassive black holes at the heart of nearly every galaxy have been these silent giants, their secrets totally locked away. But now, for the very first time, we have the key. We can finally translate their whispers. So the only question left is, what are they going to tell us first?